There is a dimension beyond that which is known to math. It is the middle ground between the dark and the stars. It lies between our present understanding and the summit of human knowledge. This is the dimension of imagination. It is an area which we call the foreshadow zone.
Integrals are, of course, antiderivatives. At least, that is how we've done things in the past. But the past is not the future. In the past, functions with one input and one output were easily differentiated and anti-differentiated. It is not so in the future with functions with multiple inputs. Therefore, we turn from indefinite integrals as a way to integrate to the definite integral. This, in turn, requires Riemann sums over higher dimensional domains, realizing the integral as a potentially complicated limit. Such definite integrals make sense, but how do we compute them? We will find a wonderful tool at our disposal in the form of the Fubini theorem. This allows us to integrate a function iteratively, working one variable at a time, anti-differentiating. This will be our main tool. But the hard part will not be in computing the integral. No, the hard part will be determining the limits of integration. For when we integrate over a complicated shape, the limits have variables in them. This will challenge your ability to see in 3 dimensions. Are integrals useful over higher dimensional domains? Yes. Yes, they are. What did you think the answer to that question was going to be? We're going to see some familiar and some new applications, some in physics to mass distribution, moments of inertia and solid body mechanics, some in probability with applications to data and statistics. Integration techniques will mostly focus on one wonderful tool, a generalization of U substitution that is known as the change of variables theorem. This kinda looks complicated, but we shall see how useful this is in solving difficult integrals by taking advantage of novel coordinate systems. Systems such as cylindrical coordinates, spherical coordinates, and more. These coordinate systems are not limited to 3D. We will travel beyond the bounds of these 3 dimensions, moving to the 4th dimension and higher. We shall see spheres and spherical coordinates that tie together geometry, analysis, probability, and much more. Gaussians will become our new favorite function as we see applications of high-dimensional integrals to all manner of problems Everything from portfolio management to tracking, sensing, filtering, data fusion, and more.